Hello students, and welcome to the video on trigonometric odd-even identities. And before we get going into the trigonometry of this, let's first start by reviewing what an odd function is. So an odd function algebraically is a function where f of negative x is equal to negative f of x. And it is symmetric with a 180-degree rotation around the origin. For example, this function, the x to the third, f of x equals x to the third, this is an odd function that's symmetric about the origin. In other words, if I take this picture, rotate it 180 degrees, you can see that I have the exact same picture as I did before, the exact same graph. And so when it comes to trigonometric identities, we have a function that is also odd, and that's the sine function. Okay. So I'm going to graph the sine function over here, and from this, from what we know about sine functions, it's going to look like this. So go up and down and back up again. This is at 0. This here is at pi. This here is at 2 pi. And then on this side, the negative side is going to go down and up and then back down again. So this is going to be negative pi, and this is going to be negative 2 pi. And you can see that this function here is in fact odd. The sine function is in fact odd because you can take this and you can turn this picture 180 degrees and you get the exact same graph again. And so one of the things that we can conclude then is if we apply this definition of odd function is that sine of negative x, or rather I'm going to use theta since I'm working with angles here. Sine of negative theta is going to be equal to negative sine of positive theta. Okay. So this is true for all theta. And you can sort of test this with yourself and check a couple of examples. For example, what if I had negative sine of pi over 4? Is that really equal to sine of negative pi over 4? Well, sine of pi over 4 is root 2 over 2 with the negative in front of it, and then sine of negative pi over 4, that's down here on the unit circle. That's down in this corner right here. So that is also a negative root 2 over 2. So you can do this with just about any angle, with anything on the unit circle, anything not on the unit circle, and you can see that this is always true. So the main point to take away from here is that the sine function is odd, and the sine function obeys the definition of odd functions, which is sine of negative theta is always equal to negative sine of positive theta. Now to switch gears a little bit, let's talk about even functions. And if you recall from earlier in the year, the definition of an even function is that f of x is equal to f of negative x. So for example, the f of x equals x squared function looks like a parabola with the vertex at 0, 0. And we know that this is symmetric over the y-axis. In other words, if you use the y-axis here as a sort of a mirror, the left side and the right side are mirror images of each other. And so one of the important results from this, if we look at the trig function, cosine of x, this is also even. So if we look at the graph of cosine, it starts up here, goes down, goes back up. On the left side also goes down, goes back up. And you can certainly check this on a calculator. This is these points right here, this is 2, let me draw this line a little bit better here. Yep, so this here is at 0, this is pi over 2, this is pi, this is 3 pi over 2, and then over here where the maximum point is, that's 2 pi. Okay? And this is symmetric because if you look at the left side and the right side, they are mirror images of each other. And then one of the things that we can conclude from here is that cosine of x, or cosine of theta, will always be equal to cosine of negative theta. So we're just applying this definition right here. F of x is equal to f of negative x for even functions. Since the cosine is even, cosine of theta is equal to cosine of negative theta. And this should mostly be review for you, since we've definitely talked about even functions before, and we've also talked about cosine functions before. And we've definitely dealt with these graphs. So keep these scenarios and these rules in mind as we proceed on to some more complicated topics, such as analyzing polar equations, where we're going to have to use the trig ratios and the trig identities, particularly the odd and the even ones. So this is should be a relatively gentle review. Go ahead and watch the next videos that you can see how some of these trig identities are put to work, and they are used to help us study more complex graphs and complex functions.